Okay, and we're back. We're ready to finally finish up this last part of example 10.7, which is involved, it's involved trig, it's involved conservation of energy, and now we're going to use our most recently learned skills of conservation of momentum to find out what the initial speed of this bullet, or which looks kind of like a ball, is going into this pendulum bob right here. And what we established in the last video was that the velocity, we called it the final velocity, really, of part one. I'll call this 1 and this 2. The final velocity of that, which is really kind of the initial velocity of this next part, but the final velocity after the two objects collide, we'll say, after the collision, was 1.94 meters per second. 1.94, I don't know why I put a period there, or a dot, meters per second. That's important. Why? Because using conservation of momentum, we can use that to find the initial velocity of this bullet right here. Let's write down everything we know. Let's write down all our givens about this whole system now. We can basically ignore this second part right here because we've done that already. The first part simply involves a simple collision. And this is going to be an inelastic collision because we have two objects, both with mass, and when the one object collides into the other one, they stick together, or they become one single mass. So let's write those givens down together. We know that the velocity of the ball and the bullet, and shouldn't call it a ball. Let's call it the pendulum, P. The bullet and pendulum is 1.94 meters per second. Okay. And let's see, what's the initial velocity of the pendulum? In fact, I should put a little f in here too. V final of the bullet and pendulum, because that's really what we found before. What's the initial velocity of the pendulum? Well, it's just sitting there, so that's 0 meters per second. And what is the initial velocity of the bullet? Well, that's the big question. That's what we want to find out. But we do know that the mass of the, let's say the bullet first, mass of the bullet is 0.05 kilograms. That looks like 50 grams, I guess. Okay. And the mass of the pendulum, or the pendulum bob, the end part, is 1.50 kilograms. So let's write out what we know about conservation of momentum. We know that the total system momentum before is equal to the total system momentum afterwards. So we can say that the momentum of the bullet plus the momentum, that should be a P. The momentum of the pendulum is equal to the momentum of the bullet and the pendulum. Simple enough. But we know we can break that down into MV, and MV and MV. So the mass of the bullet times the velocity of the bullet plus the mass of the pendulum times the velocity of the pendulum equals the mass of the bullet and the pendulum times the velocity of the bullet and the pendulum. That's our conservation of momentum right there. Well, we're almost done. We're almost done because this right here, the velocity, the initial velocity of the bullet is what we want to find, and we know everything else, so we can simply solve for the velocity of the bullet. So let's see. I'm going to write this over here. Actually, I'm going to go further up here just so it's more centered. The initial velocity of the bullet. Let's see. Let's take this whole thing and subtract it on both sides. I'll just do this in steps. Mass of the bullet times the velocity of the bullet equals this minus that. Mass of the bullet and the pendulum times the velocity of the bullet and the pendulum minus this right here. Mass of the pendulum times the velocity of the pendulum. And wait a minute, why am I doing this? Because after all, what is the initial velocity of the pendulum? That's 0 anyway, right? That's 0, so that whole thing goes away. So basically, our initial velocity of the bullet times the mass of the bullet is equal to the mass and velocity of the bullet and pendulum together. So, initial velocity of the bullet is going to be equal to, let's divide by the mass of the bullet, mBp times the velocity, bp, divided by mass of the bullet. Easy enough, right? So what's the mass of them both together? We know that's those two added, 0.5 plus 1.5. 1.5 kilograms plus 0.05 kilograms. That's the mass and the velocity of them together. We know that because that's what we spent all that time solving. That's this right here, 1.94. 1.94 meters per second. And we simply divide that by what? We divide that by the mass of the bullet. It's 0.05 kilograms. Hey, sweetie. My little Boston Terrier just came in. And that'll give us the mass of our bullet right here. This is what we've been doing all this work for. Not the mass, the initial velocity of the bullet. So 1.55 times 1.94 divided by 0.050, and here's the final drum roll. It should be 60.1 meters per second. And as I cross out the S there, let's do that again. 60.1 meters per second. That's our final answer. That's the velocity of the bullet. And if you think about it, you need to ask yourself, does that make sense? Well, yeah, 60 meters per second. That's pretty quick, and bullets tend to travel pretty fast. So that's our answer. We've used trig, we've used conservation of energy, and we've used conservation of momentum to take a swinging pendulum and turn that into what the initial velocity of the bullet is there. So there you have it. That's example 10.7. And I hope that gives you a better understanding of the relationship between all these different conservation of energy, momentum, and trig as well. So that's it. I'll see you on the next video.